in C++ and in Python, we kind of touched on this, but kind of didn't at the same time. I don't remember if I ever introduced you to an array in Python, but the in C++, you have a notion of data structures, and they're pretty important. Um, you have a notion of data structures in every programming language, but the reality is that these are, how you have like kind of an int, string, and like all those primitives.
Hmm.
Well, data structures are like the more advanced form of that. And so they essentially contain, you know, collections of data. So rather than just like a string, they contain a bunch of strings uh, or a bunch of numbers. And they kind of fall into three categories, at least according to ChatGPT. And I somewhat like these. Um, there's linear data structures, which means like the data is like ordered in a line. There is associative data structures, which are mostly like key value pairs, where like if I have a particular key, it could be a code word or it could be a number. I use that to retrieve the value that's associated with that number somewhere else.
Okay.
And then you have the ability to define your own custom data structures, which I'll try to show an example of. We'll see how far we get today. And then you have like some really like specialized data structures, which I honestly don't know a whole lot about, but I'm sure we could figure them out if we cared enough.
Mhm.
Um, for today's focus, what I was going to try to do is focus on arrays, in particular, focus on fixed or uh, arrays, vectors, lists, and if we get time, probably a map.
Okay.
We'll see. If we have time, we'll do that, but we probably won't. So these are the most common. That's the reason I'm focusing on them. But I want to give you kind of a one-on-one description of what each of these are. And I kind of wish I could almost write it out, but I'm going to verbally talk about it. Maybe we'll write it out as we go. But let's start with an array actually. In memory, so we were talking about pointers and references and like values and just like memory addresses.
Hmm.
Well, in the actual like memory chip itself, all those addresses and everything are like in a line, synchronized. So like you index another number and you move over, and they can store a certain amount of bits. And so what we talk about when we talk about like arrays, is that we're talking about grabbing a fixed chunk of memory that is in a line in the RAM and saying we want to store data in that memory as a collection, and that data is called an array when it's in like a fixed line and it's a fixed amount that you've kind of reserved. So when you declare or define an array, you reserve that memory so that it can't be used by other pieces of the program. Essentially,
Hmm.
it's now reserved for your data structure. A vector, you can think of a vector as an array that you can resize. So an array is fixed, meaning if I say I want like 5 slots, I only have 5 slots. I can't like add a sixth slot to the array. But with a vector, I can add a sixth slot. So it essentially, and there's all these fancy things that'll happen in memory where like if there's not enough in a row, it'll like move it to another row and then add
Hmm.
more. But it still keeps it in a sequential line. A list, the reason I chose it is because it's not a sequential line. It basically, is, I will take, I will store things in my list and they will be, random pieces of reserved memory all over the matrix grid of the RAM. And they'll be connected to each other by, um, by a reference to the memory address of the next piece. So like from your perspective, you might be like, this is like, somewhat ordered, but from the memory's perspective in the RAM, it's like all over the place.
Hmm.
So you can go through your list and it'll be like, what's the next element in my list? And it'll see like it is. But because it's all scattered in the memory, it's slower to retrieve certain information. Now, those three are like critical, and we're going to go through some examples of these so that it's a lot more clear. The reason I brought those up in the ordering and non-ordering is because you want to pick the data structure that you're going to use based on how you're going to retrieve the information. And we'll talk about something called big O notation and computational complexity at some point. But the reality is that if I know the number and the order of the array that I need, like I know I need the fifth element,
Mm-hmm.
then it's way faster to use an array to retrieve that data, because you're essentially saying, go to element number 5 in memory and just grab the data. The difference here, and by the way, I was checking you, John, Justin. The difference for like a list is that you're not going to element number 5. You're going to the start of the list, and you're going 5 over by like finding the reference, going to the next one, finding the reference, going to the next one. Then when you reach 5, you then return that memory. So Justin, we're talking data structures real quick. Just to recap here, what we're going to talk about is today's focus is primarily going to be on vectors, arrays, and lists. And if we have time, maps. And there are really 3 types of data structures, or 4 types of data structures. They are essentially collections of information. And Justin, if you could mute when you're not chatting, that'd be great.
Sorry.
Good feedback.
Office is new.
Yeah. So linear data structures are where, from your perspective, everything is ordered. It's like 1, 2, 3, 4, 5. And I have a collection of strings or a collection of other objects or a collection of integers. For associative containers, I basically have the ability to find something with a key value pair. So if I have the key, it could be a number or a word or a UUID. It could be anything. Some type of like primitive information. I can insert that into my data structure and retrieve from memory the thing that I want. So containers are like key value pair oriented, whereas linear data structures are just a sequence. And then there's a couple other things. You can define your own data structures. We'll talk about that at some point. And then there's like really specialized data structures. And I don't know a lot about those, but I'm sure we could figure it out if we cared. But we probably don't. So back to these. We're talking array, list, and vector. An array is literally just a chunk of memory in order, like 0, 1, 2, 3, 4, 5. It'll be a more complex hexadecimal memory address, but you get the point, that you reserve for your array. So you reserve it when you declare it. And you can't make the array any bigger. You've reserved that piece. But that also means that if you create another array, it can't go and take that same slice of memory in the matrix grid that is like the RAM. And so a vector is a array basically that's resizable. So it's still ordered, but it's resizable. And the way it gets around that is I believe that if it can't actually just add more pieces to the end, it copies the data over and then adds more pieces. Maybe it does a reference. I honestly don't know. Can't remember. We could talk to ChatGPT about it. But for functional purposes, a vector can be resized and an array cannot. There's also a list. And the reason I wanted to describe this one, these are the first 3 that are common to teach in computer science, is because a list is not, from your perspective, it's in a row when you're programming. But from the memory's perspective, it's not in a row. It's scattered all about the memory. So I might have like a list that is A, B, C, D, but A is in one giant area, and B is in another area, and C is in another area, and D is in another area. And the way in which the compiled program searches for a particular element in that list, like say you need the 3rd element, is that it has the memory address of the thing that's first, and then the memory address of the thing that's second. So that list will then go and grab the data. It will look at it can grab the data on the first one if it wants. But if you're going for element 5, it's going to be like, all right, go to the first element, look for the reference, find the memory address of the second element, and then go over here, and count 5 times and be like, okay, I'll return that one. An array, if you say I want the fifth element, it just says go to the memory address that is like the fifth element, because it's all in a row. It basically is like a +5 operation, which is super quick. And I was telling Rachel that the reason this is all important is because if you have massive amounts of data, the way in which the data structure you use has a big impact on performance. And a lot of this can be described in something that's called big O notation, which is a description of the complexity or number of steps required to complete an action. And so, for a doubly linked list where you have to go in order through all the elements, we call that big O of n, meaning it's linear and it takes n number of steps to get there. So it takes like the number of steps you need to get there in a sequence. It doesn't have to loop back, doesn't have to do anything else. But for a vector and an array, or especially for an array, if you just focus on that for a second, it's a big O of what we call C, meaning, or big O of 1, meaning it's constant. So the amount of searching does not change, even if you had an array that is like 1,000,000 wide. You can go directly to this element. If I have a list that's 1,000,000 wide, it's going to take a long time to linearly search through all those to get to the final one. So that's why those are different, even though they do similar things.
So for that, right, like a list, you have to do like a for loop to go through each one, and that's like
You
the
don't,
one. And then
yeah,
the array you can directly access an indice, right? That's why it's
yes, essentially. I got to remember how a list works. It might be that it does it automatically. We'll look at it in a second when I get to the example. But
and then
essentially,
isn't like
it's doing a for loop. You have to have a for loop to get there.
and then isn't like Lago the best or something?
That's actually for search, not for. I'm gonna write some big O notation here. Big O notation is big O of n here. Oh, sorry. This is for.
That's about the only thing I got from the data structure class
Yeah.
I audited at it.
Yeah,
I remember the big O's.
that's for sorting algorithms, which is after data structures. So this is big O of C. And the reason that that's important, or I was going to say we'll just get into an example here and then we'll talk about it. So I've already written an example, so this is pretty easy. So I have a more complex example, but first I wanted to type it out so that you could kind of see the way this works in real time. So if I have int and I say my array and I declare an array on the stack, the way that you do this, or define an array on the stack, the way that you do this is you have these curly brackets and then you put, you have to do, I'm actually going to change this to a character because I want to make it a little bit easier to see. So A, and then you kind of build your list, right? And I have to also define with this bracket how big the array is. So the array is going to be 3 elements deep, which means I can have 3 elements in it. And I define them in the same line for this example. And now that they're 3 deep, if I want to retrieve that element, I can do cout or std cout, and I can say my array, and then I can do 0 std and this will print the value at index 0. So in computer science, we always start at 0 to 9 rather than 1 to 10. And so the first element in this list is at the index of 0. And so all I have to do now is save and compile my program and print, and I get A. If I want the second element, I do the same thing. I can go directly to the second element, which would be at index 1, and directly to the second element at index 2. And now I have ABCD or ABC. Pretty simple. Any questions on just defining an array real quick?
Good here.
Sweet. Alrighty. So that's defining an array. I have this other example. It's a little bit more complex, just for purposes. So we have our fixed array. All arrays are fixed size at declaration. So I've declared that it's going to be 5, and then I defined it in the same line to be these numbers. I had ChatGPT build this, so I'm reading it with you. But essentially now I have a for loop, and I just want to go through and I want to print out all the scores. These are like test scores. And then I also want to modify an element. I want to modify element at the third index, 0, 1, 2. So I'm going to use 2 as the third index to change the third index to 95. And then honestly, what I might even do for the sake of example here is just recopy that down and show you 2 arrays. So the first one is, just the elements printed out. The second one, that third element has been changed from 88 to 95. And so that's how arrays work. You do a fixed size and you run. They're really nice from a efficiency standpoint because all your data is super ordered, super fast to retrieve. And so that's where an array kind of is powerful. However, it's fixed, which is not so useful because a lot of things you want to do in computer science, you want your data structure to be variable size. Hence where vectors come in. So let's do a vector example and comment this out. Vectors are very commonly used. So I'm going to do vector. I'm gonna have to do std. I think it's vector. Right? Hold on. Let me grab a vector example. Give me vector example. My brain's trying to remember how to do syntax here. See it for like 2 seconds. It's vector int. So okay. So vector, and we're gonna do the same thing that we did before, but we're gonna have to make the vector. So I'm gonna make it on the stack. Is it vector? Vector. I spelled that right. And I gotta name it. We're just gonna call it vec. Vector is undefined. I just defined it. Oh, A scores. No, I want to do it on the heap. On the heap, please. It's nicer on the heap because it's what's more used. Oh, do I have to do a pointer? Then I'm gonna do it on a stack. If you're gonna do it on the heap, you have to make a pointer first. You might be able to get around that with some fancy stuff, but why am I getting syntax error? Oh, I didn't import vector. So vector's got a pre-processing directive. That's what's going on here. So it's a class in the standard library, but you have to import it so that you can use it. And so we have a vector now declared on a heap. And if I want to search the vector, it's a syntax search. I don't care how push. I want to do a search. It's pretty similar. It'd be faster just to copy this ahead, but here's the situation. I don't want to do that yet. So with a vector, right, this is basically functionally the same thing as an array right now, right? So we're going to do our little for loop. I haven't taught you that yet, so I'm going to make it pretty clear. And I don't think I've taught you for loops in C++. I can't remember if I did or didn't. The syntax is more like a while loop in Python than it is a for loop in Python, but it's way more common in all the other languages. They all use this sort of syntax. So it's like your start condition, your end condition, and the amount you want to increment after each loop, and then just the inner contents. So like this is an integer. I'm going to start at I equals to 0. And while I is less than scores dot size, which is the size of this vector, I plus plus, meaning after you've gone a loop, you index I by 1. So the first time it's 0, the second time it's 1, the third time it's 3, and then once it gets to 5, I will not be less than 0, and the loop will stop. So GCC, if there's any questions, feel free to interrupt me. So for here, looks the same as an array, right? I grabbed with the same brackets, I grabbed just the indexes and I printed them out. But here's the trick with a vector, is I can do scores dot push, and I can add another one. So I'm going to add 1,000, 10,000, because this student's really good and they did all the bonus and they cheated the system. And so what I end up with now is 5 elements in the vector, and the 5th one is that one. You can also pop a vector. I'm pretty confident. Maybe I'm a little bit, yeah. Moves the last element. So if I want to pop what I just pushed, probably would be more effective to show it this way. And you pop and you choose the element you want to push. Oh, sorry. Actually, it just pops the last element. You don't need to put anything there. So I'll tell you what each of those are, but I want to get it printed out here. All right. So pushback or push operations work for a lot of different data structures. You'll hear those when you hear stacks, when you hear vectors, when you hear etc. That basically means like, hey, append to the end of that list another thing that I'm going to tell you. Pop says remove the end, like cut out the end. And so as you're starting to see, all the data structures can get pretty complex, especially when you add shared memory in there. And they, certain ones are better for certain operations. So if I have a certain amount of collection data that I need in a sequence, because I want to be able to have like constant time operations, then I can use a vector. And let me double check that I said that right. Is a vector element retrieval a constant time operation? Yes, it is. Okay, so I did it right. So you have a vector is basically an array that's all ordered, fancy, and sequence, and it's a constant time operation. So what we're faced with here is we want to use a vector because we want to retrieve, let's say we wanted to retrieve the 5th score in the list, and we just knew that was the element that we needed to retrieve, and we use a constant time operation to grab that element. So a vector is great, but or an array would even work for that. But a vector will work if you're like, I have an array, but I actually don't know how big the array will be. It'll be a variable size. I'm not going to be able to define it ahead of time, and I might have to make it bigger as we go along. That's when you use a vector. So that's also why vectors happen to be used more often. And so you got push pop operations. And by the way, if you're ever curious, like what operations I could do on an object that is a vector, you can go here. You can look it up on the C++ standard. You might be able to do like front push or like some other fancy stuff to it. I don't really remember right now, but push and pop are pretty common. Any questions on vector?
Good here.
All right.
Yeah,
So
no
we're
questions
almost
here.
we're almost out of time. But I'll describe to you briefly what a list is, also known as a linked list or a doubly linked list. Give quick list example. I don't want all that. No, I just want something super simple. All right, so this is what a list looks like. We'll go over this more next week, but essentially you're gonna, and I also have to do the import of the list, but I'll do that later for the sake of time. That'll make that error go away. Now I have a list and I can push and pop. So functionally, as you can, I was going to say, as you can see, now I'll show you something. It might be a little bit more complicated, but like when I go to retrieve an element, I am now going to have to go advance through the list to find the element that I want down the line. And so it adds another layer. However, it's actually better for certain operations. And my mind is blanking on which ones those are. There are definitely uses for a list where a vector is not appropriate. And I'll come more prepared next week as we dive into lists to tell you about it. Sound good?
Sounds good.
Sounds good.
Wait, I have to
We're
remember all
back
this
in
on
our
the fly.
software sessions.
We're back at it.